Hi, this is Brian Fogarty, and this is a video for Chapter 10 of the book Quantitative Social Science Data with R, second edition. So in this video, what we're going to do, this is the first video of Chapter 10, is we are going to look at crosstabulations, usually abbreviated as crosstabs. So this chapter is all about bivariate analysis, which you should be able to guess that involves analysis of two variables. This is a sort of an introduction to analyzing effects between variables, analyzing where we have a predictor variable and an outcome variable. Commonly, the predictor is called independent variable, the outcome variable is called a dependent variable, but there's been a switch away from that usage just because it implies causality, which in a lot of the analysis we do in the social sciences, that's something we can't really show. So what I've done throughout the book is use and discuss things as using the predictor variable, predictors. Another term people use are covariates for independent variables, and then outcome variables as a usage for dependent variables. All right, so sorry, a little rabbit hole there. Okay, so what we're going to do is we are going to look at whether there is a relationship between people's responses on if they think voter fraud is a problem and their vote in the 2017 UK Parliament election. So I have my R markdown file here. I've set my lib path, working directory. I read in the data, or I loaded tidyverse, read in the data, fixed the problem with fixed the problem with VF problem, again because it automatically is read in. The categories are automatically read in alphabetically. All right, so let's just take a look here, just to remind us what these look like. We've used these before in other videos here. So VF problem 1, we're calling it, goes from strongly disagree to strongly agree, and then vote 2017 dumb has two categories. So if the respondent voted for the Conservative Party, they're coded as a winner, and if they voted for a different party, then they're coded as a loser. And then there's a bunch of missing, which are people that did not vote. Okay, so we want to do a crosstabulation. So this crosstabulation is just a table between two variables, hence cross. And we want to see, as a first look, whether there appears to be any relationship. So here what I'm going to do is treat VF problem 1 as our outcome variable and the vote 2017 as the predictor variable. Okay, so there are a whole bunch of ways we can possibly do a crosstabulation in R. I don't really like any of them, to be honest. I feel like Stata's tab function is so much easier to use. And the reason why I say I don't like them is just because they're not really simple to implement. But I kept looking for ways, and so I think the way that's in the book and that we're going to look at today is pretty straightforward, all things considered. Okay, so we are going to use a function, and I was just thinking about this. I don't know how to say it. I've been saying it in my head as tabyl, but it might be table, just spelt weird, like someone changing the spelling of their name to look cool. Anyway, all right, let's get to it. So what we need to do is we need to load the package janitor. All right. As you might expect, janitor is a package with a bunch of functions that clean up variables. I've used it a couple times to create data sets for Stata, because there's some functions that can help with that. All right. So it's one of the nice things about this is that it's the basic function for getting the crosstab is really easy. and it's also tidyverse friendly. So we're going to do VF England. All right, use our piping, and then we saw all those missing values. So we don't want to look at those. Sometimes people do want to look at missing values in analysis. That's not our goal here. So we're going to filter it out and say remove any missing values on vote 2017 dumb. Okay, and then we're going to do, this is where, so table, I'm going to say tably because it sounds fun. So tabyl, and then our outcome variable, which is going to be another way to think of it is this is our row variable. And then our predictor, which another way to think of it is this is our column variable. Okay, so let's highlight that and run that. Okay, so we see here we have VF problem going this way. These are our rows. And then the vote 2017 is our columns here, loser, winner. Notice that it is a little, this really basic presentation. So we have VF problem here going down this way, but we actually don't see the name of the variable here for vote 2017. I don't think it's a big deal. All right, so these are just the raw percentages. Okay, or not percentages, I'm sorry. These are the raw frequencies. So the problem with this is it's kind of hard to figure out what's going on. Especially because we don't have the totals there, which makes it even more difficult. So it's a little tricky. So when we use crosstabulations, usually we want to add some more things here. All right, so that's what we'll do. We're going to add some more stuff. We're going to add it using piping. Okay, so the first thing is that we are going to add percentages. So we're going to add percentages. So how to do that, there's all these functions. You can see them come up here. It's adorn underscore. And adorn is kind of a fun word. I don't really see that many functions in R or elsewhere with adorn, so I kind of like it. So adorn percentages, and we want column percentages because there's also a whole bunch of different types you could do. All right, and then we want to format those percentages. We're going to do adorn PCT formatting, and we're going to include digits equals 1. So what that will do is that will give us 1 decimal place. Okay, all right. Remember I mentioned, oh, no, it went, okay. And then the last thing we're going to do is include adorn NS. And then just open like that. So this is to add, to make sure to add in the actual frequencies here. All right. So let's highlight that, run that. Okay, so we'll see like this is the frequencies, this is what we had in the previous one, but now our percentages are here. So what we do is we look to see, does there appear to be any difference between winner and loser across these values? Is there a trend at all? Do we see anything? Somewhat, right? We see that there's higher percentages of winners slightly agreeing, strongly agreeing. What I should point out is that these percentages are based on the column totals. Okay, so that's why this is 9.2, this is 7.7, even though they almost have the exact same frequency. Okay. I do a couple other examples in the chapter on this, but it's pretty straightforward. So we look at this and we use this to tell our story. But this isn't telling, this doesn't give us anything about whether there is a statistically significant relationship, the strength of the relationship, anything like that. So that's what we'll do in the following videos. All right, so that's it. Thanks for watching. See you next time.